Okay, good evening, everyone. It starts because it's heavily rain. We'll see what happened. I think that's why participants are all here. Only 14 are here. It's okay, let's start. Because not sure about the thundering and it's raining. There's heavy rain here. Okay, then I want to tell you that I uploaded all the lecture notes and presentations to your LMS. So then you can download it. Thereafter, I don't upload it into a WhatsApp group. Then you can take it from LMS. I already uploaded 6 sessions there. So you can take it from there. Because there are some problems in WhatsApp. Sometimes it may erase or something. There were problems. That's why I did so. Yes, it's raining everywhere. We'll see what to do. Okay, today we are going to talk about session 7. It's organizing classroom tests and classroom uses of descriptive statistics. Before that, can you hear me? Because of raining, there's a message, my internet connection is unstable. Can you hear me?
Can hear, madam, but it's lightning and thundering.
Yes, yes. So, in previous day, We did about assessments, evaluation, then what are the traditional methods of evaluation and new trends. Under that, we discuss about new things, rubrics like that. Then we did reliability and validity. Please mute your mic. Okay, then today we are going to talk about under organizing classroom test, table of specification or blueprint. We did it in the previous lesson also, but here we also discuss about that. Then development of test scores, analysis of test scores. Under that, we are going to discuss about difficulty index and item discrimination or discrimination index. Then preparing the final question paper. Then under unit number 10, classroom users of descriptive statistics 1. Under that, organizing of test scores and necessity of descriptive statistics. So organizing classrooms. Organizing classroom tests are very, very important because of those unit tests or classroom tests. Sometimes it may be monthly test, unit test, or term test. Then they give us effective reinforcement for the students and also for us as teachers. That is also a reinforcement and also for students. Because the process of reviewing because of the results, the students can understand what are the previously covered materials, and they go through always. They are going to went through those lessons, so they can memorize those things. Then it helps students to identify their strengths and weaknesses. Through exams, students can understand concepts more deeply and gain better understanding. Then also teachers can take their own reflection about their teaching. Then table of specification or blueprint. So we did it in the session 6 under validity. Which type of validity can be tested using specification table? Can anyone answer? So before that, tell me, can you remember what are the 4 types of validity? There are 4 types of validity. Tell me one by one. If I remember you,
Construct validity.
yes, very good. Construct validity. Then
Content validity.
yes, content validity.
Predictive.
Phase validity.
Yes, face validity, predictive validity is also there. So predictive validity comes under criterion validity. Very good. I'm very happy about you. Under criterion validity, concurrent validity and predictive validity is there. Then under which validity we can use a specification table to test which validity?
Content validity.
Yes, very good. Content validity. So you know now you did something about specification tables for your assignments also. So then you may have a broad idea about this. So this is important tool. So because educators can use this to ensure accurate measurement of student learning. So it's a very, very powerful teaching tool. Instead of that, it gives us assessment planning and also These are the other uses of that. When blueprints are created before the topic or unit is taught, before the unit, if we can prepare the blueprint, then the educators can go into those instructions, and then it gives a guidance to the instructor also. It gives a highly vision how to conduct the lesson, and the students can get the idea what are the areas I should give my attention very well, like that. Then the students are more likely to achieve learning goals with clearly specified specification table. When the educators start with clear vision of that they want students to know and be able to do, they set students up to succeed. So by looking at the specification table, the educators can get the vision of their lesson. How should I deliver the lesson? What are the assessments should I do, like that? Then if we can distribute the blueprint among the children before the lesson, then the students can get the idea of what they need to learn, what is going to do, what are the areas I should give my attention very well, like that. It's a very, very important tool. Then this is another example. Previous day I gave you one example, and this is another example. It's about high school physics. Don't mind about the subject. This is just I want to tell you about the types of blueprints. Actually, there are several types of blueprints. So by looking at them, you can create your own blueprint. There is no any guideline or anything. The necessities you have to include what are the cognitive level you are going to measure, what are which type of questions you are going to give them, like that. You have to give the guidance using the specification table. So if you can give the guidance using the specification table, then it's okay. There is no any standard way of making the specification table. Only only thing is it should include the necessary things. That's all. So as example, in this first column, it gives the objectives. What are the objectives? So the first one, define Newton's laws of motion. So that teacher or lecturer going to evaluate the students under the Newton's laws using remembering questions. It means the lower level cognitive questions. He's planning to give 3 remembering questions under this session. So then when we go to fourth one is calculate the velocity components of a projectile at the maximum height. So under that, he decided to give 1 remembering question and 1 application there. So altogether there are 2 questions. Likewise, there are total 12 questions. Under that, remembering, there are 7 remember questions. To check the understanding, he is going to give 2 questions. Then 2 questions from application, 1 question from create. So this is regarding only one, like a unit test. This is about 1 unit. So from the 1 unit, he is planning to give 12 questions like this. Sometimes this 7 may be MCQ questions. This 2 may be also MCQ or something. So this application and creation, sometimes it will be structured or essay one. like that. So by looking at this, the instructor can design which type of questions am I going to do, like that. So there is another example. It is a mathematics test. Another type of blueprint there. Here, understanding transformations. Under that, here the question number is also mentioned here. So it is very, very well planned one. So knowledge and understanding, he is going to give essay question, that is 2B, under question B, question number 8, essay 2B. Part is on understanding and transformation. Like that is, yes, it's like that. Then under understanding and transformation, he is going to give also a comparative 2 questions, essay question, question number 1 and question number 6. And from application part, question number 4, 2 questions. So altogether 5 questions from understanding and transformation part. This is the subtopic of the lesson. This is total, there are 3 total main lessons under this unit. So he is planning like this. So these are pre-planned specification table. In your assignment, I ask you to analyze the given paper using the blueprint. That is the, so likewise, we can use the blueprint in any way to analyze the paper or also to design the paper. And then 9.2, development of test scores. So the process of developing of test occurs in 5 stages. You know about that. That is test conceptualization, like making the blueprint or specification table. Then test construction. It's like by looking at the specification table, we can organize the questions. That's it. Then test tryout. After making the questions, we have to test it using the sample. By using 10 or 20 or 30 students as a sample, we have to give those questions and evaluate their answers. And as we discussed in the previous session, then we can calculate their validity and reliability. And then if there is not validity there, then we have to omit such type of questions before going to the final paper. So that is test tryout. Then item analysis of by giving the sample to the children, then we have to analyze it. Then test revision. So then we have to specify the purpose of the test and the influence to be drawn. Then develop frameworks describing the knowledge and skills to be tested. Then build test specifications. Then create potential test items and scoring rubrics. Scoring rubrics is like a marking scheme. Before giving the question paper, final question paper to the students, we have to make a marking scheme by stating how many marks for each stage, and in detail we have to make the marking scheme. So then we are going to analyze the test scores. So it is need, an analysis part is very important, because as a whole and the individual test items, and to use these data to draw valid inferences about student performances. The teacher can get the valid reflection about the students' performances, how they perform, how they face the questions. Then this is information is helped to teachers to prepare post-test also. By after evaluating the test, we can discuss the what are the common errors they do in the class, in the exam. Like that, we can post-test, we can do post-test discussions with students. Then item analysis helps teachers examine assessments and figure out if there are a good measure of testing their students. As example, if the test is too difficult, so wasting time by giving such type of test is useless. Then if the test is too easy, it is also same. No need to give such type of a test. Therefore, we don't use a too difficult test or too easy test. So we have to give moderate test to students. Analysis of test scores is important, whether we can identify, we can analyze about our paper, whether it is too difficult, too easy, or moderate. Without analyzing the difficulty of that, if we give distribute it to the children, and if it is too easy, it is time wasting activity. So it is very important. Analysis part is very important. To analyze the test scores, we have to use two indexes. Here, I told you that if the test is too difficult or too easy, to analyze whether it is too difficult or too easy, we can calculate difficulty index or convenience index and discrimination index for the test scores. So when we go to difficulty index, or it is called convenience index, it is calculated using P equal R over T. P is the difficulty index. R is the number of correct responses. T is the number of total responses. It is as a fraction. We can have the answers 0 to 1 for difficulty index. If that difficulty index is greater than or equal to 0.9, it means 1 or 0.9, it means that test is too easy for that sample population. Usually we calculate this difficulty index or convenience index using our sample test, sample population. So sample test, by taking the responses of the sample, we can calculate this difficulty index. If it is greater than or equal to 0.9, that is too easy. If it is lower than or equal to 0.1, that is too difficult. So both of these types we can't generalize. Then if it is, so the normal range is 0.2 to 0.8. So if it is 0.5, it's moderate, it's okay. So normally in the mastery examination, our difficulty range is, the test difficulty range is, average difficulty is 0.7 or higher. That is for like aptitude tests. That is for mastery examinations. Usually we have to try to keep the difficulty index between 0.2 to 0.8. If it is 0.5, it's fine. Then discrimination index. It describes how well the item discriminate between well performances and lower performances. Here, when calculating discrimination index, we consider the responses of only one question. That is the importance of that. Discrimination examines one question at a time and compares high-scoring students' answers and low-scoring student answers. You can understand it by looking at this formula. Discrimination index equal number of successors by the high group. Here high group means number of students who obtain higher marks. Assume that our population is 50. So we distribute our paper to among 50 students. Among that, there are 15 students who got high marks. High marks means above 75. So other 35 students get low marks, that is below 75 marks. So here the number of successors by the high group means here high group is 15. High group is 15, that is the number of students who got high marks, that is high group. So number of successors by the high group, it means among those 15 students, if we want to find the discrimination index for fifth question, assume we want to find the discrimination index for fifth question. So among those 15 students who got high marks, we have to find who gave correct answer for fifth question. That number should come here. Among 15 students, how many students give correct answer for fifth question? That is here. So then number of successors by the low group, that is, I told you that there are 35 students who got low marks. Among 35, there may be some students who gave correct answer for fifth question. So that number comes here. And we should divide it by total number of students in the test. If in this example, that is 50. So then we can get discrimination index. That is, that gives the how well the students perform this particular question, like that. Like question wise, we can calculate discrimination index. So the overall point of item discrimination is to confirm that individual exam questions differentiate between the students who understand the material and those who don't. We can get the idea how many students can understand this type of learning area. Because we consider questions one by one. So we can we can have very good analysis here by using discrimination index. So evaluation reports are distributed. Evaluation reports are made using this type of indices. So using this type of indices, this type of results, we can create bar charts also. Then by looking at bar charts, we can summarize our results. There are so many benefits. So then preparing the final question paper. So from the previous session, we discussed about validity, reliability. Now today we discuss about specification table and indices, difficulty index, discrimination index, like that. All are in order to prepare the final question paper. So the first step is preparing the blueprint. Already we discussed about that. So the second one is prepare questions. Based on the blueprint, we have to prepare questions. Sometimes if there is a syllabus change, so we have to, the teacher has to prepare the new question. So it consumes so much time. Therefore, within one night, we can't make a very good valid paper. So we have to use time by analyzing those items. So the third step is prepare marking scheme. It is very, very important. Marking scheme is basically a step-by-step solution. It should give step-by-step solutions for each and every question. So it describes how marks will be allocated for the students. Therefore, preparing marking scheme is very, very important. And also when prepare, sometimes after evaluating after finding the discrimination index, difficulty index, like that, we can prepare the final paper. No? So after preparing the final paper, we can grab some types of printing mistakes or some other minor mistakes when preparing the marking scheme. You know about that. So before distributing the paper, we have to prepare marking scheme. So at that moment also we can correct something. So there is a chance for corrections at that moment. Still there is a chance. So then we have to check the paper for face validity. We discussed about face validity last day also. That is the readability, the words without printing mistakes, the paper should include the correct punctuation marks, and so we have to keep the required space to write the answers if like the structured questions. Then we have to careful not dividing the question into 2 pages. We discuss about this. So that is face validity. Actually, face validity is very weak measurement of validation, but we do it because at the final moment also we can have such type of errors like printing mistakes, punctuation mistakes. So then by considering face validity, we can minimize such type of errors also. So that is about preparing the question paper. So then now we are going to start statistics part. And this is the latter part of our course unit also. Classroom uses of descriptive statistics. When we consider statistics, there are 2 types of statistics: descriptive statistics and inferential statistics. Both are very, very important, but most probably in classroom uses, we use descriptive statistics. Actually, you presently also, you as teachers, you all use this descriptive statistics: bar charts, pie charts, tally marks. So I think there is a new format, S1 format. You have to enter the marks for S1 format. Then automatically it gives the bar chart like that. So then descriptive statistics are there. It is very, very important part. So this is the difference of 2 types of statistics. Descriptive statistics useful for main 2 things. That is, it provides basic information about variables in data set. And also it highlights potential relationships between variables. So under descriptive statistics, we consider about central tendency measurements, variability measurements, distribution, standard distribution, mean distribution. So those are the things we discuss about descriptive statistics. As example, assume that the marks in class A is 70 for maths like that, any subject, 70, 85, 90, and 65. So by calculating the mean value of it, that becomes 77.5. For class B, the marks are 60, 40, 89, and 96. So the mean value becomes 71.25. So by looking at the mean value, we can understand that the average marks for class A is greater than class B. So no need to go the data one by one. By looking at the mean value, we can get the rough idea. That is therefore descriptive statistics. So inferential statistics are more deeper than that. That is a tool we use to draw conclusions about the characteristics of a population using the sample. Here, we use the sample and we analyze some characteristics. Then we are going to generalize it for the population. That's it. Then we are going to determine how certain they can be of the reliability of those conclusions. It is used to generalize the large groups, such as example, estimating the average demand for a product by surveying a sample of consumers' buying habits. We can estimate the demand for our product by surveying the consumers' buying habits. And then we can predict the future of that product. That is inferential statistics. So like that, by looking at the marks for a particular subject, for the sample, we can generalize that we can generalize it for all island students using inferential statistics. For inferential statistics, we use chi-square test, t-test, ANOVA test. If you refer those things, you can find ANOVA test, MANOVA test. Yes, ANOVA, MANOVA. Such type of tests are there. So here, chi-square test, t-test, ANOVA test, MANOVA test, NANOVA test. Those tests, for those tests, we have to we have to use hypothesis. We don't go in deep for that. So we discuss about descriptive statistics. So for your knowledge, you can refer those things. We only discuss about in a particular session, we discuss main things on inferential statistics. So descriptive statistics, there are main three parts in descriptive statistics: frequency distribution, central tendency measures, and measures of dispersion. So today we only discuss about frequency distribution. That is the basic or the foundation for descriptive statistics. So today I lay that foundation. Then in next session, we are going to discuss about central tendency measures and measures of dispersion. So under central tendency measures, we will discuss about mean, median, mode. So measures of dispersion, range, interquartile range, variance, and standard deviation. So that will be the next session. So organization of test scores. Organization of test scores is organizing the scores or marks in a meaningful manner. There are main 4 methods of organizing test scores. Those are ranking method, arranging the scores in a frequency distribution, and arranging the scores into a frequency distribution with class intervals, and then arranging the scores into a cumulative frequency distribution and a percentage frequency distribution. Those are the 4 main methods of organizing test scores we are going to discuss today. That is under frequency distribution. So first one, rank in the scores. You know about ranking. We did it earlier also. Ranking means arranging the given scores in descending or ascending order. In statistics, usually we use descending order. And sometimes we have to give place values for those numbers. There are main 3 methods of ranking the scores. Wait. This example, the marks are given as 60, 42, 57, 70, 40, 61, 32, 48, and so on. Then we have to arrange those marks in descending order. Let's see how to do it. Yes, it's here. So in descending order means we have to arrange these marks from highest to lowest. What is the highest mark here? What?
70, right?
Yes, 70. Then the other one, next highest mark is?
61.
Yes, 61. Like that, you can arrange these numbers in descending order. Then the second method is we tabulate those scores like this as given. Then we have to give the numbers. So number 1 for the highest mark. So here number 70 here. So we give number 1. So next 61 number 2. Like that, we give numbers. This is another method of ranking. In previous day, we discussed about if there are similar numbers as 61, 61. There is 2 61s here. We have to give 2.5, 2.5. Like that, we rank the...
Excuse me, madam.
Yes.
If more than 2 or 3, then we have to divide it.
Yes, we have to divide it by 3. It means if there are 2 marks, this position is 2 and 3. If the positions are 2 and 3, we have to add 2 plus 3 divide by 2. 2 plus 3, 5. 5 divide by 2, 2.5. Then if there are 3, if those places are 4, 5 and 6, then we have to add 4 plus 5 plus 6 and divide by 3. Understood?
Yes. Yes, madam. Thank you.
Yes, madam.
Okay. Then the third method is, here also we arrange the marks in descending order and then give 1, 2, 3 like that. So most probably we use method 1 and method 2 because method 3 is already ordered, no? So then that is the ranking scores, ranking of the scores. So second one, arranging the scores into a frequency distribution. Here we use ranking method. Tell me, can we rank the numbers like this if there are 50, 60 numbers?
It's
Is it
difficult.
easy?
It's difficult.
Yes, it's difficult. Therefore, if there is only a small number of ranks, we can use this. If the number of scores are greater than about 20, we have to use frequency distribution. To do that, first we have to identify the maximum and minimum value. Then arrange them into ascending order. Then we have to put tally marks and mention the frequency. So arrange them in ascending order is not a law, that is a rule. Normally we use ascending order in statistics. If you want, you can order them descending. It's okay. We can't say that it's wrong. No, that's not wrong. So the normal way is this. So this is the example. For our convenience, I got only this number of, there is only about, I think, 17 numbers. So we use frequency distribution for more than 20 numbers. Here, the maximum number is 20. Then the minimum number is 10. So according to these steps, identify maximum value and minimum value. Now, then we have to arrange them in an ascending order. So maximum number is 20. Then 20, 19, 18, like that we go in ascending order. Then we have to put tally marks here. Number 10. So then number 14 here. Number 20 here. 13. 17. 14. 10. 11, 13. I kept it to do it with you, otherwise you can't understand. No, that's why. 14 and 11. Here you can see when we arrange, first we identify what is the maximum value and minimum value, then we order them, then we put the marks in descending order like this, 20, 19, 18. So then according to the given data, there is no mark as 19. So leave it. Also 16 here. So then we are going to give the frequency here, 20. There is only 120 mark by looking at the tally marks. Here, no, so put 0. Then again 1, then 2, again 0, again 2, then 4, after writing the frequency here, the total frequency, if you add the number of frequency here, if you add these numbers, so the total frequency should be equal to the number of data here. Four, 5, 6, 7, 8, 9, 10. Then yes, 17 here. So there is 17 data. If you put tally marks correctly, this number of data should equal to the number sigma f here. Sigma is the addition I told you previously. So it equals 17. So this is the frequency distribution table. This is also easy. So the third one. So if there is only small amount of data, we can use ranking method. If the number of data is greater than 20, we have to go for frequency distribution. Then, if the number of data points are more than 20, like 50, 100, 150, we can't tabularize the data like frequency curve, frequency table like this. If there is 100 marks, then we have to put so many marks here. So it's not practical. But then we have to go for third one. That is arranging the scores into a frequency distribution with class intervals. When using class intervals, we have to consider several points. So the first one is, first we have to find the real limit of the class interval. Real limit or actual limit. To find the actual limit, we have to subtract 0.5 from the lower value and add 0.5 for the upper value. Using this example, you can understand that. It means consider the class interval as 5 to 10. Consider that you have class intervals 5 to 10 and then 11 to 15. So those are two class intervals. When you consider 5 to 10 and 11 to 14, see, yes, 11 to 16, sorry. I marked it in the number line. This is called number line. If we mark those ranges in the number line, see, 5 to 10. So the numbers, so the data between 5 to 10 are here. So the data between 11 to 16 are here. So what about the data between 10 to 11? If there is a data called 10.6, so what happened to it? So that is why we have to use this real limit or actual range of the intervals, class intervals. So by dividing the data into class intervals, we can have discrete values. 0 to 4, 5 to 10, 11 to 16. Like that, there are discrete values. So there is a gap between one interval to another interval. To bridge those gaps, in order to bridge that gap, we have to use this real limit. That is why this is, if the class interval is 5 to 10, this number 5 is called lower value. So that is lower value. So the real limit, lower real limit is, to find the lower real limit, we have to subtract 0.5 from the lower value. So the lower value is 5 now. So then we have to subtract 0.5 from 5. That becomes 4.5. That is in the middle. So then the upper value is 10. To find the real value, we have to add 0.5. So that becomes 10.5. See? Then the second interval is 11 to 16 now. When you consider 11 to 15, so the lower value is 11. So to find that lower real limit, we have to subtract 10 minus 0.5. That becomes 10.5. Understood? Then both are overlapping here. Then we can have continuous range, continuous intervals. That is why we have to find the real limit. If there are class intervals like 5 to 10, 10 to 11, 10 to 15, 15 to 19 like that, that's okay. No need to find the real limits because there is a continuous intervals. But here we have discrete intervals. Therefore, we have to find the limits, real limits. Understood? Are there any questions regarding real limit? No questions. Let's move to the next one. So the second one we have to consider is midpoint or mid value of the class interval. That is the middle value. To find that, we have to add upper value and lower value, then divide by 2. We can use it using limits also. Upper real, we have to add upper real value and lower real value and then divide it by 2. This example, the class interval is 5 to 10. So to find the mid value, 5 plus 10, 15. 15 divided by 2, 7.5. Then using limits, we can also find that. Then 4.5 plus 10.5. That is also 15. 15 divided by 2 is 7.5. That is how to find the mid value. Then the third point, we have to find the width of the class interval or the range. Not the range of the total data set. Here we consider about the range of the class interval or width of the class interval. To find the range of the total data set, we have to find minimum value, maximum value and subtract them. But here we have to find the width of the class interval. So we have to calculate it using this one. Range equal maximum value minus minimum value plus 1. If we use lower and higher values, if we use limits, no need to add plus 1 here. Maximum lower limit minus minimum lower limit. Here it should be minimum lower limit. There is a printing mistake. Minimum lower limit. Because when you consider upper value and lower value, before the lower value, there is 0.5 here. After the higher value, there is also 0.5. That is why we have to add plus 1 here. But when you consider limits, there is 0.5 and 0.5 here. So no need to add plus 1. So example, if the class interval is 5 to 10, so range equal 10 minus 5, that is 5. 5 plus 1, 6. So if you use limits, that is 10.5 minus 4.5. That is also 6. So the difference is 0.5 here. In these two methods also you can calculate range or width of the class interval. Then, not only that, so as a revision, first we have to find the real limit. Then we have to find the midpoint by add and divide by 2. Then we have to find the range of the interval. Now determine the range of the class. We have to determine the range of the class. When determining the range of the class, usually the range it is in statistics, it is better to have the range with odd value. See, if the range is 50, if the class interval is 15 to 19, so the range is here 19 minus 15, 4, 4 plus 1, 5. So the range is 5 here, that is okay. In this interval 10 to 12, 12 minus 10, 2, 2 plus 1, 3. That is also okay. Here range, finding the range. Here we have to add 1 when we use values. That is why I add here. Now 19 minus 15, 4, 4 plus 1, 5. Then in the class interval 6 to 9, so 9 minus 6 is 3, 3 plus 1, 4. So here the range is 4. So that is not suitable because it is even value. Usually we consider odd values for class ranges. Then we have to determine the class intervals. Usually for the frequency distribution, it is better to have 10 intervals or nearly 10 intervals. But it depends, that is the normal. Normally we use, it is better to have 10 intervals or nearly 10. It means 7 intervals, 11 intervals like that. So number of class intervals equal range divided by width of the class. Total range. Now here the range means not for the class interval, that is total range. It is the total, by considering the total data set, we have to find the minimum value, maximum value when subtract them. Then you can find the total range. And then you have to divide it by width of one class. Class width here. Width of the class or class range. Then you have to decide the lowest class interval. So to decide the lowest class interval, there is a law and also a rule. According to the law, the lowest value of the dataset should be included to the class interval. The lowest value should be included into the class interval. The rule is, when you consider the class interval, there are two values, no, upper value and lower value. So for upper value or the lower value, the class interval should be class interval or the multiple of class interval should be there. You can understand like this. Assume the lower value of the class, if the lower value of the class is 7 and the width of the class is 5, then according to the law, we can define the class intervals. The lower value is 7 now, so then you can start from 7. So the class width is 5. It means we have to add 7 to, we have to add 4 to 7. 4 to 7 is 11. Class width is 5 now. Class width is 5 means, see, 7 to 11. So 11 minus 7 is 4. 4 plus 1, 5. That is, the width of the class is 5. Then the lower value is 7. So you have to start from 7. So, so the class intervals are 7 to 11, then 5 to 9, 7 to 11, 6 to 10, 5 to 9, 4 to 8, 3 to 7. That is, so the lower value of the class is 7. So then the class width is 5 now. Then 7 to 11. We have to add 4 to 7, that is 11. So width is plus 1, another plus 1. So then take 6, 7. So in the previous class interval we took 7. We start from 7. Then now start from 6. 6 to what? 6 to 10. We have to add 4 here. Then 7, 6. Then take 5 and 9. Then 4 to 8, 3 to 7. Here the starting point 7. Then 6, 5, 4, 3, descending order. Again, the upper value also 11, descending order. 11, 10, 9, 8, 7. The interval starts, the first interval is starts from 7 and the last one ends from 7. You have to start from 7 and end from 7. It means you have to start from the lowest value and the end from the lowest value also. By looking at another example, you can understand that. Then the rule says that the upper value or the lower value of the class interval should be the multiple of the width of the class. Now the width of the class is 5 now. So multiples of 5 are 5, 10, 15. So multiples of the 5 are, here no multiples, 7 and 11 no multiples. But when you consider 6, 10, 10 is multiples of 5. So according to the rule, the upper value or the lower value should be multiple of the width. Here, the upper value is multiple of the width. This one, lower value is multiple of width. So according to the rule, we can select only these two classes. 6 to 10 and 5 to 9. 5 to 9. So by looking at the range of the given data set, we can determine that we have to start the interval from here. And then we have to decide the width of the class. Then we can define several class intervals. Then by according to the rule, we can take out what are the suitable values there. Then we can carry out the suitable ranges from the listed values. Is it clear? Please do it with me. Consider the following examples. The lower value of the class is 5. The width of the class is 3. So what are the class intervals? The lower value of the data set, actually not class, the lower value of the data set is 5 and the width of the class is 3. So how to start? Can anyone tell me?
Five to seven.
5 to 8.
5 to 7 or 8?
7.
5 to 7, not 8. If you take 8, assume, if you take 8 here, now 8 minus, to find the width of the class, we have, there is no limit, so the value is here. So the upper value is 8 and the lower value is 5. After what is 2 here? You are ask something in the chat. I can't understand that. If you put 8 here, 5 to 8. So find how to find the class width? We have to subtract upper value from the minus value and plus 1. So 8 minus 5, 3. 3 plus 1, 4. If it is, the class width is 4. To have the class width 3, we have to, yes.
5 to 7.
Yes, 5 to 7. Then another one.
Four to 6.
Yes, 4 to 6. Another one.
3 to 5.
Yes, 3 to 5. Are there any? No, no need to go beyond this because here we start from 5 and end with 5. Now we have to consider the rule. This is according to the law. We can
5
assume
to
that,
7. 3 to 5.
yes. So according to the rule, the upper value or lower value of the class should be multiples of class width. Here class width is 3, no? So multiples of 3 is 3, 6, 9. So here no 3 here. 3 or 6 or anything. Here upper value is 6. Here the lower value is 6. So we have to consider these two class intervals. Another one. The lower value of the class is 10. The width of the class is 7. Then how to start this? We have to start from 10. 10 to
16.
yes, 10 to 16.
16.
Then next one,
9 to 15.
yes, 9 to 15. Next one,
8 to 14.
yes, very good. 8 to 14.
14. 7 to 13.
There are so many. 7 to 13. Then
6 to 12.
then
5 to
5 to
11.
last one.
4
Yes, very good. Thank you, Miss. 4 to 10.
10.
Now, what are the considerable class intervals according to the rule?
8 to 14.
Yes. 8, 14.
7 to
Yes, and
13.
7 and 13
7.
only because the multiples and the Are there anyone who can't understand this? There's a style here. If you find that style, it's easy. Okay. Then this is the example for frequency distribution table with class intervals. Then by looking at this class interval, tell me what is the width of the class? What is the width of the class?
5.
Yes, 5. 74 minus 74. Answer 4. 4 plus 1, 5. Yes. See the upper limit or lower limit is the multiple of class width. Class width is 5. So 70, 65 all are multiples of 5. So this limit, upper class interval and lower class interval is determined according to the given data range. What is the maximum one? What is the minimum one? According to that range, we have to define the class intervals, and then here frequency 10 means there are 10 marks or data. There are 10 data points within 70 to 74. There are 20 marks within 65 to 69. This is how to analyze frequency distribution with class intervals. By looking at this, we can say that what is the range which most of the students obtain marks? What is the range?
64,
Yes.
60 to
Very good.
64.
60 to 64. Very good, miss. Then the lowest number of students obtain
25 to 29.
20. Yes, very good. 25 to 29. Likewise, by looking at this type of tables, also we can grab some information. So the total number of students are 250 here. So again, if there is only a small amount of data points, we have to use ranking scores. So then if there are more than 20 data points, we have to use frequency distribution like this. But if there is more than 20, more than 50 or more than 20, no, more than 50, 100 like that, then we have to go for frequency distribution with class intervals. In order to calculate frequency distribution with class intervals, we have to consider what is the real limit, then midpoint, then width, range of the class, then minimum class interval, and according to the law and rule, we have to decide what is the lowest class interval. This is the example. So then, the fourth one, arranging the scores into a cumulative frequency distribution and a percentage frequency distribution. Arranging the scores into a cumulative frequency distribution and a percentage frequency distribution. Cumulative frequency means the number that describes how often a value in a data set occurs, as well as how often its previous values occur. That indicates how often the total previous values behave. That is cumulative. So we can calculate cumulative frequency by adding the frequency with its own value and the before frequency values. If the number of data sets is very large, we have to use this. The steps are, we have to find the lowest and the highest value of the data set. Then find the range. Then determine the width of the class interval. Determine the lowest class interval. Then design the frequency distribution table. So we have to obey these 5 steps. It means by looking at the given data set, we have to define what is the highest value. So by looking at this data set, the highest value is 54. The highest value is 54. Then the lowest value is yes, 14. So by looking at the highest value and lowest value, we can find the range. So the range is 54 minus 14 plus 1. 54 minus 14, 30, 40. 40 plus 1, 41. So the range is 41. Then width. Width is decided, no, usually width is decided by the user or the calculator. If you are going to analyze these results, then you have to decide what is the class width, which I am going to use. If you are not given take the width of the class interval as 3 like that, you can use any width by your own. But it should be convenience to the data set. So the width is 5. So previously I told you the number of to find the number of class intervals, we have to find the range and divide by the width. So the range is 41 divided by 5. That becomes 8.5. There is no half value for intervals now. Therefore, we have to define 9 class intervals. Assume that this value becomes 8.1. Is it 8? Shall we take it as 8? What is your idea? Shall we take it as, assume that the number of, if the value for number of class intervals, you obtain 8.1. So can we assume that as 9 or 8? What is your answer?
8.
8. Another answer?
8, madam.
8 is correct. When you round off 8.1, that is 8. Okay. When you round off 8.5, that is 9. That is also okay. But the number of class intervals means within these intervals, we have to cover all the range. Range means 41. Means from 54 to 14. So the number of class interval value becomes 8.1. It means the number of class intervals are going beyond 8. Somehow beyond 8. Therefore, if we use 8 here, we have to lose some data. Understood? Here, we are not going to round off the value. If the value is exact value, that is okay. If we get any decimal point number, it means fraction, we have to round off to the largest one. 8.5 means 8 intervals are not 8.1 means 8 intervals are not enough to represent the data set. Understood? Therefore, you have to use 9 intervals. If it is 8.1 or 8.01 or if it is 8.01, that is also above 8. Therefore, we have to go for another next value, 9. Understood?
Yes, madam.
So then we have to define the lowest class interval, which we did in the last movement. Lowest class interval. To find the lowest class interval, here the lowest value of the data set is 14. By obeying this rule and law, we can define it. So the lowest value is 14. So the class width is 5. Then by looking at these two, 14 and 5.
14 to 10.
Yes. 14 and 5. We can't get exactly the lowest class interval is like that. We can't take. So we have to, by looking at this 14 and 5, we have to,
10.
yes, we have to suggest some other intervals also. By starting from 14, then it becomes 14 to
10.
yes, 10. Very good. Then
13 to 9.
9. Then
6, 12 to 8.
very good. Then
11 to 7. 10 to 6.
no,
No.
no. We can't take 13, 12, these intervals. Why?
Multiple. Not suitable.
Not here, not multiples, but we have to write the suggest the ranges, class intervals within 14, no? Within 14. So 13 to 9, 12 to 8, there is no 14 here.
Done.
So no need to. We have to consider only these two, 10 to 14 and 14 to
10.
no. No. 14 to 10, 13 to 9, then yes, you're correct. Sorry.
12 to 8.
Yes, 12 to 8. Sorry, you're correct. 11 to
7. 10 to 6.
yes.
Ten to 6.
10 to 6.
9.
10 to 6.
Yes.
9 to 5, madam.
Yes. Then 9, 5, like that. So width should be, the upper value or lower value should be multiple of 5. So that is, according to that, we can select these three. No?
Done.
Yes. So among these three intervals, 14 to 10, 10 to 6, 9 to 5, you can select any interval as lowest class interval. Here 10 to 14 is, we have to start from
10.
lowest one, no, that is why 10 to 15, 6 to 10, 5 to 9. So here, in this example, they consider the lowest class interval as 10 to 14. Means 14 to 10. So no need to define the highest class interval. When you start from 10 to 14 and then go by defining 9 class intervals, you the ending one is 50 to 54. So no, therefore no need to find the highest class interval here. So according to the steps, we finding the lowest and highest value, then we found the range, then determine the width, then determine the lowest class interval, and the final one is design the frequency distribution table. So now we define width, we found the lowest class interval, and then we are going to define the frequency distribution curve. Before going to the frequency distribution curve, you have to know these terms. CF for cumulative frequency. That is the frequency of occurrence of values less than a reference value. So the percentage can be calculated like frequency divided by total number of data into 100. And percentage cumulative is also the percentage of frequency occurrence less than the reference value. So the total cumulative frequency should be 100. Because we total up the frequency percentages here. Therefore, the maximum value for percentages is 100. So this is that data set. So then, as we discussed, the lowest class interval is 10 to 14, then 15 to 19, 20 to 24, 25 to 29, and the last one is 50 to 54. By putting tally marks, by analyzing this data, we can have tally marks like this. And according to the tally marks, the frequency is this. I guess Shara asked the frequencies, about the frequencies. Yes, we can take 14 to 18. Upper values also we can take. Here, 14. Here we consider 14 minus 4, that is 10. Like that, we define the class here, no? So Shara asked, can't we define the class intervals like that, 14 to 18? That is also okay. Then 13 to 17. 12 to 16. 11 to 15. Yes. 10 to 14. Yes, this method is also okay. This is the method which we discussed earlier. Yes, this is also okay. And according to the width, we can consider multiples of 5. So we can consider 11 to 15 and 10 to 14. Here, they consider 10 to 14. So actually, this is the method we discuss in these examples. Here, yes. Can't you log into LMS for your lecture notes or something? Is it difficult? Or are there any errors in the LMS? Okay, let's move into the lesson. So according to the frequency, according to the class intervals, we can put tally marks and get the frequency. Then cumulative frequency. That is, we have to add each and every frequency from lowest class interval. So the lowest class interval frequency is 1. Put 1 here. Then put 1 to 4. The previous frequency. 1 to 4 is 5. So when we consider 5 means that range is 15 to 19. No? By looking at 5, we can analyze that there are 5 students who took below 19 marks. That is how we interpret it. That is why we use cumulative frequency. Then 5 plus 5, 10. 10 plus 6, 16. 16 plus 4, 20. 20 plus 4, 24. 24 to 6, 30. Likewise, so the upper value is 40. It means the total number of students, here the total frequency is also 40. If we do the cumulative frequency correctly, so this total, when you total up frequency, it is 40 here. That value should be in the upper value. Here, if we take 30, 30 means there are 30 students who took below 44 marks. Below 44 marks. That is why in the upper, in the previous slide, that is cumulative frequency is the occurrence of values of a phenomenon less than a reference value, less than. That is why we have to go from lowest value means lowest class interval to the upper intervals. Then we have to take the percentage of these frequencies. So when we consider frequency, percentage of frequency, that is the here the 50 to 54 frequency is 6. Then 6 divided by total number of students are 40 into 100. That value is 15. Here I mentioned the method here. Then 4 divided by 40 into 100, 10. Then 5 divided by 40 into 100, 12.5. 1 divided by 40 into 100, 2.5. The percentage is here. Likewise, we have to calculate percentage. Then we have to consider the cumulative percentage frequency. That is also like cumulative frequency. Here we have to add percentages. 2.5. 2.5 plus 10, 12.5. 12.5 plus 12.5, 25. 25 plus 4, 15, 40. Likewise, the upper value is 100. If you add these percentages correctly, that is 100 or nearly 100. Actually, if now for this example, it's okay. There are divisible numbers. No, if this is number 3 here, what happened? Wait. If we have to, if the frequency is 3, then we have to find the percentage as 3 divided by 40 into 100. That is 7.5. Then if it is 7.5, this becomes, by adding all of these things, 7.5 is also okay. Assume that this here the if you get the percentage mark, percentage value as 14.3, then 85 plus 14.3 becomes 85 plus 14.3 becomes 99.3, not 100. So that is why the cumulative percentage is most probably 100. Sometimes there may be nearly 100 values. 99.3 means nearly 100. Because of this, when we calculate frequency, percentage of frequency, all of the numbers may not be rounded numbers. Therefore, the final cumulative value may not 100. It is nearly 100. Here the percentages are divisible numbers, so that is okay here. It seems that if we here it is 7 or 9 like that, we can have percentage point marks. So this cumulative frequency table is very important to calculate mean, median, and mood. So this is the basis of statistics. Then to go for a central tendency measurements like mean, median, mood, we have to use this table. So please go through how to calculate these columns, and then for our calculations we have to take addition of these or all of these columns. That is why I put sigma mark here. Then we have to find the total of frequency, then total cumulative, like that. For in order to find standard distribution, which we are going to do in the next session. So that is how to find the how to design the cumulative frequency distribution table. So that is frequency distribution. So then the last part. That is necessity of descriptive statistics. We can use descriptive statistics to provide basic information and also highlighting potential relationships. Then it summarizes the large amount of data into several useful bits of information. It helps businesses better understand their customers, improve workflows. It means by calculating mean value, we can, as example, I told you, we can get the idea that what is the customer feedback about our product, like that. So by using such type of data, we can improve our products. We can take some decisions based on that. Then descriptive statistics are used to describe characteristics of set of data. Descriptive statistics in everyday life can be seen in charts, graphs, charts showing employment rate, new college graduates over past 5 years, like that. Those are the examples. So it is very, very important in especially classroom tests. This is the example. It's not example, exercise. You have to, by looking at this data, you have to find the range. Range means before you have to find the maximum value, then lowest value, then find the width. Not width, but range. Then you have to decide what is the class interval. Then by considering that width and class interval, you can find number of class intervals, divide by them. Then you have to define the lowest class interval. And then write the class intervals here and then put tally marks and calculate those things. Actually, it is better you do this by yourself before the next session. It's very, very useful. So those are the things I want to discuss with you today. So today we discuss about the classroom tests, how to define that, how to prepare final classroom tests, and then we started the statistics. Under that, we discuss about frequency distribution. That is the basic of statistics. Are there any questions regarding this? If you have any questions, you can ask. Then
Madam,
yes.
Madam, this question is related to table of specification. There's a example in our textbook. It's already about a paper. It means the first paper, MCQ question. So in vertical side, they mention the marks or the question numbers. They put from 1 to 40. But if we make a table of specification for a second part or the English paper, it's difficult for us to mention all the questions because we make the paper for 100 marks. So at that time, how can we add the marks or all these things?
At the marks. So in the
Yeah.
second paper, no need to write the, just mention only the question number, and then you can analyze whether which when you consider that particular question, you can, by looking at the question, by reading the question, you have to have the idea what is which level, what is the level this question represents. It means, is it knowledge, understanding, or anything? Then you have to put tick it there. Did I answer your
Okay,
question?
madam. Thank you.
Did I answer?
Yes, ma'am.
Okay.
Thank you, madam.
Okay. Just put only the question number as in this way. Here. Like this.
Okay.
So then someone asked me to share the PDF of session 6 and 7 here in the chat box. Who is that? Gayani, are you here?
Yes, madam.
Then okay, I will share. So then you can, I will put it into the yes, chat box. Then you can download it, no? Are there any questions? So no point to attach here, no? In chat box? Can't attach. Why? Attach mark is not here, no? Can you see the attach mark? Can anyone see?
No, madam.
No, yes. So do you want to share it in the WhatsApp group? I think it's not useful. That's why I WhatsApp group.
No, madam, please share in the WhatsApp group.
Oh, okay. As well, I also share it in LMS also. Then you can download it anytime. Okay, I will put it into the WhatsApp also. Then if there is no questions, let's wind up this session. So
Thank you, madam.
during this month, we have to complete this course. Okay, then good night, everyone.
Thank you, madam. Good night.